So this is the second video, and it's going to show how we can use modern OpenGL and a process called Vertex Array Objects and Vertex Buffer Objects to offload our data from the client side, i.e. our program, to the server, which is OpenGL. So similar to the last program, I have my matrix for my view project. I now have, instead of a stood vector of NGL vec3s, this single GL uint, which I've called MVAO. This is a identifier that we'll get from OpenGL to represent our point data when we set it. And again, I've got my create points and my update points. Now first off, we'll look at the initialization in our program because it's slightly different before. I'm going to use shaders this time because modern OpenGL doesn't have the fixed functionality pipeline that we had previously, and we're going to have to implement this ourselves by writing a shader. So the basic setup is exactly the same as before. I've got my view and my perspective matrices setting up my view projection. And now what I'm doing is I'm using NGL's built-in shader library. You can obviously load the shaders yourself if you wish. And NGL has a built-in color shader. It's the simplest of shaders we can really write. And it looks a little like this. It has two parts. The fragment shader is very simple. It sets the current fragment to be the color, and this color is passed in as a uniform that we have to set ourselves. By default it will be black. And our vertex shader has, in this case, a uniform called MVP, which is going to be our modeling, viewing and project matrix, and an input which is called invert. There are possibilities to have others in this. This is a generic shader I use. In this case, I'm only ever going to input my vertex, so these will be ignored. And what I do is I set my current vertex position to be model view project times a vec4 of invert and 1, so this is an affine transform and translations will take effect. So this shader is loaded here as it's one of the built-in ones. I'm setting the color of the point to be white. I'm then calling create points. Now create points is a lot more complex now because before we were just going through setting our vector. This time we're storing our vector here, so I'm creating my stood vector of vec3s called point, and I'm resizing it when I construct it to be the correct size. I'm looping through and I'm setting this values. And as you'll notice, this is basically going to fall out of scope because it's an automatic variable when this function is called. So this is never going to be retained on the client side of OpenGL. Now I'm going to create a vertex array object. Now a vertex array object is a state object within OpenGL, and it will remember any buffers that we create and any vertex attribute pointers that we set. So it's a state object that remembers the current state when it was set, and we can recall that very quickly. If you look in the help on the blog post, there's a link to the man page for this. So when we create this, we pass in how many we want to create. In this case I only want one, but we could actually create a bunch of them, and the address of the starting point. In this case it's only a single GL unsigned int, so it's only one rather than it being array 0. Before we use this, we must make this the currently active vertex array object. OpenGL uses a bind to edit metaphor, so what this is doing, it's binding so that we can edit this currently active vertex array object to make it active. Now that this is active, any subsequent calls will be stored as part of the state data for this vertex array. So I'm now going to create a buffer. So again, similar sort of process, only this is a buffer object. So I'm going to store this ID. Again, this is local. This will be stored within the current vertex array state for us. So I'm going to generate one single buffer and I'm going to store that ID. I'm now going to bind, ready to edit, and make it the currently active buffer, and this is a GL array buffer, indicating it's a buffer of array data. Next, I'm going to copy the data into that buffer. Now, because a stud vector is guaranteed to be contiguous, this data is all one after the other, and it's basically an array of floats, I can tell it how big the data is in bytes. So it's the size of the stud vector times the size of what it's containing. So in this case, a vec3. So that's going to be my 1000 times 3 times 4, which is the size in bytes of a float on this architecture. Next, we have to tell OpenGL where that data begins in the array that we're passing. So it's beginning at this memory address, which is basically the beginning of the stud vector. And finally, it's a hint on usage. So in this case, this data is not going to be updated much, so GL static draw. Now that data's been copied to the server side, to OpenGL, we need to tell OpenGL the size and the layout of this data. Now, if you're familiar with some of the earlier OpenGL versions, this is more or less the same as a call to GL Vertex pointer, and what this is doing now is just using the generic Vertex array pointer syntax rather than GL Vertex pointer, GL normal pointer, GL color pointer. So in this case I'm saying there is a generic attribute pointer. It's the 0, 1 in our array. Generally there are 16 of these. The size of it, in this case there are 3 elements, it's a vec3. The data type, that's GL float. Whether it should be normalized, I've set that to GL4 so it doesn't need to be normalized. Then we tell it the stride, so how much of a step between each consecutive one of these in the data stream that's coming into the shader. As this data is tightly packed, that stride is 0, so it will just go every 3 floats. And then finally the offset into the array where that data begins. And in this case again it's a coercion from null plus 0. So this is saying that it's a floating point pointer starting at 0 in our array. Then finally we must enable this attribute array so that OpenGL knows that this one's being used and it will pass the data. In this case I'm then unbinding the vertex array by setting it to 0. This just makes sure that there are no subsequent calls. It is possible to, if you're only using one vertex array, never unbind it, which in theory could be quicker. This is most probably safer. My update points method is, again, very different from the previous version. First thing I'm going to do is to create a new array of points, because obviously we didn't store the last array of points. So I'm resizing this stud vector, I'm looping through, I'm populating it with data, and now I'm going to rebind this vertex array object that I created previously. I'm going to bind the buffer that was in there, and then I'm going to, so I've noticed there that that's most probably incorrect, and that should just be the 0 buffer. I will leave that in there for now. I'm going to copy that buffer data across. Again, it's a similar sort of thing as before. And then I'm going to unbind the array. Next, when I draw, the initial part's the same, and I'm calculating my transform and my MVP. Now this needs to be transferred to the shader. So I'm setting the uniform MVP to the shader. This is using, again, my NGL shader library. This would be a call to GL uniform 4F, GL uniform from matrix, which I can't remember off the top of my head what it's called. We then bind our vertex array, and then we make a call to GL draw arrays. And this will draw the current array in the current format. We say how many we want to draw and where in our array of data to start from. So if I run this now, it's going to do exactly the same as we did previously, and you can see that I can update and change. Again, if I change this to GL lines and then just the number of points divided by 2, it will give us this drawing with lines. There's a series of lines being drawn, and by 3, and I call GL triangles, you'll get a series of triangles which will most probably block the screen out as it did previously. So you can see there, because the triangles are rather large. What I could do is GL polygon mode, GL front and back, GL line, and that should now draw that in wireframe mode just so you can see it in action, and you can see all the various triangles that are there. So this is the modern OpenGL way of drawing things. It's relatively simple once you get your head around the idea of storing the data, passing it to the server side, to OpenGL, and updating the shaders each frame.